Hi, I am Nasim Soltani, and in today's tutorial, I'm going to talk about our code for SigMF conversion. In this tutorial today, I'm going to talk about what is SigMF, what are the metadata entries, what does our code implement, how to run the code, and finally, I'm going to run an example with our code. SigMF or signal metadata format is a format for storing and sharing RF signals. It was first developed by GNU Radio in this link provided over here. In this format, each signal file is represented as one data file with .bin extension and one metadata file with .json extension. Bin files contain interleaved representation of I and Q components, or real and imaginary part of the signal, with desired precision. For example, int, float 16, float 32, etc. This is an example for float 16 precision. We can see that in this example, each I and Q occupy 2 bytes, and they are interleaved, which means we have one I, one Q, next I, next Q, and so on and so forth. JSON files contain metadata entries, which are hierarchical information about the signal. Metadata entries are contained within 3 main objects of global that contains information that applies to the whole data set, captures that contains information that applies to each transmission, and annotations that contains any other information that are not included in the global and captures objects. These are usually information, more detailed information about the recordings. For example, they can be about the distance between the transmitter and the receiver, or the details of hardwares that were used to collect the data set. Here is an example for metadata entries in an example data set. You can see that it has 3 main objects of global, captures, annotations, and within each of these objects, you can see the metadata entries. For example, in the global object, we have the data type, which is, for this example, it is float 16 with little Indian representation, which applies to the whole data set. We have captures object, for example, with transmission number entry, which is different for every transmission. And we have annotations, which has entries like the distance or the transmitter and receiver hardware details. Our code implements conversion to and from SigMF. Convert to SigMF happens for storing and sharing purposes. For example, when you collect data with your SDRs or from any other method, you can run conversion to SigMF to store it on disk or to share it, to put it online, put the data set online. Conversion from SigMF happens for processing and visualization purposes. When you download a dataset with SigMF format, you can run conversion from SigMF and process the numerical values that are generated from this block using MATLAB, Python, etc. So our conversion code uses .mat format as an example for the other side of conversion. So we convert MAT formats to SigMF format, and we convert SigMF format back to MAT formats. And we are using .mat formats just as an example. This can be edited in the code to accommodate to any desired format. For example, .npy that is common in Python, if you need to. As we said, we have 2 functions in our code: convert mat to SigMF, which is for converting to SigMF, and convert bin to mat, which is for converting from SigMF. This is a snapshot of our README in the GitHub repository. I will show you later how to run the code. But first, we just need to specify that our code takes 3 inputs: SigMF path, which is path to the directory that contains or will contain binary or SigMF files; mat path, which is the path to the directory that contains or will contain math files. Conversion, which is a switch that indicates we want to run SigMF to math conversion or vice versa. Now I will show you running an example by going to the GitHub repository here. This is our repository for SigMF conversion. And you can see that the README is over here. That shows you how to run the code. You can see that we have two files, SigMF converter, which has the two functions that we mentioned, convert math to SigMF, and convert bin to math. And it needs the three arguments that we discussed, SigMF path, math path, conversion. This Python file is run through a bash script, which is shown here. It has the three arguments that we mentioned. Now we run an example. In order to run an example, we need an example data set that is in the SigMF format, and we can convert it to math files. For this, we go to genesis-lab.org/mldatasets, which contains the datasets related to different projects in the Genesis lab. For SigMF to math conversion example, we use this hovering UAVs dataset. If you click on it, it takes you to the dataset description page, which talks about the details of the dataset, and it describes that the dataset is collected from 7 hovering UAVs and is stored and shared in the form of SigMF, which is specified here. And here is the link to download the dataset. If you click on it, it takes us to the Northeastern University library, and it gives us a download link. I have already downloaded the dataset from this link, and it is in the shape of a zip file. I have unzipped it, and I have stored it on my system here, UAV datasets folder, in a folder named UAV SigMF load 16. If you look inside the folder, you can see that it has all the datasets files, which are binary files containing the signal values, IQ samples, and each of the binary files are accompanied with a JSON file with the same name that contains the metadata file. I have also downloaded the SigMF conversion code from our GitHub repository, and I have stored it on my system here in this path. You can see the two main files of run bash script and the SigMF converter file. Now we want to run an example of how to convert this dataset from SigMF format to math format. To do this, we open the run script, and we see that the three arguments are asked for here. First, the SigMF path. We copy paste the SigMF path from here. We copy this and paste it here. We can also remove the quotation marks. They're not necessary. And I also specify that I would like the generated math files to be stored in the same path, just in a folder called UAV math files. And this could be any other given name. For the conversion switch, I specify that I want SigMF to math conversion and not vice versa. Now I save the bash script and I run it like this. And I can see that the code is going through all the binary files in the dataset one by one, and it is converting them to numerical values, and it is saving them in a math file. While this is running, you can see that in this UAV dataset folder, let me look here, another folder has appeared along with the SigMF folder, which is called UAV mat files. It's exactly the folder that we specified in the run bash file here. And inside these UAV mat files, there are all the generated mat files. I mean, at the end of the run, there will be all the generated mat files saved here. For now, 26% of them are here. They have the same name as their binary files that they were converted from. Only their format is different, and now they are saved in mat format. Running this is going to take some time. Now that the run is over, we can see that all the mat files are generated in this folder. We can also convert, run the reverse conversion by converting mat files to SigMF files. To do this, we need to change this conversion switch to mat to SigMF. And also for custom datasets, other datasets other than these hovering UAV datasets, we can convert the parameters inside the code, like the dataset metadata entries. These ones should be modified according to your new dataset. And the conversion from mat format to SigMF will run smoothly.